Hello students, today we're going to look at section 3.1, starting a new chapter, and the section today is graph linear equations. First thing we need to do is define a linear equation. So a linear equation is an equation that forms a line when it is graphed. Line, linear. Line is the first four words of linear, so you know that when you graph that equation, it's going to form a line. That's why it's called a linear equation. Okay? Most linear equations, scratch what I just said. Linear equations can be written in several different forms. Okay? Standard form of a linear equation is ax plus by equals c. Okay? ax plus by equals c, where the x and the y are a point on the line. A, b, and c are numbers. C would be a constant, doesn't have a variable with it. The x and y variable, I mean. But a and b are also coefficients of the x and y that help you figure out slope and y-intercept and all that kind of stuff. Okay, so that's standard form. You'll need to know that that's standard form, and you'll be able to look at it and say, oh, that's standard form of a linear equation. You've probably seen it most as y equals mx plus b. That is a different form of a linear equation, and it derives from standard form we just solved for y. But for you, what you need to know right now is you need to know that that is standard form when you see it. Okay? The other thing that you need to know, like how do I identify a linear equation? Okay, well, first of all, in order for it to be a linear equation, x and y must have an exponent of 1. Okay? The other thing you need to know is that x and y can't be multiplied or divided by each other. That's not a linear equation. The only thing you can have is an x and a y. Sometimes it's only an x and sometimes there's only a y, but you have to have that x and y with an exponent of 1. For example, y equals 3x plus 2. That is a linear equation. Okay? Something like x times y equals 5, that is not a linear equation because x and y are being multiplied by each other instead of added and subtracted. Something like x equals negative 7, that is a linear equation. There doesn't happen to be a y in here because y equals 0 since it's not there. There's an x equals negative 7, there's no crazy exponent, so this actually is a linear equation. Let me adjust a bit. And then something like x squared plus 3 equals y. That is not a linear equation because the exponent of 2. You must only have an exponent of 1 for it to be a linear equation. The next thing you need to know about linear equations and lines is I thought I was going to draw these with two really contrasting colors and just messed up. This is a pink line, this is a red line, so we're going to look at the pink line first. Something you need to know about linear equations is that they have intercepts. Okay? Intercepts are the points where the line crosses one of the axes. Okay? Remember, this is the y-axis and this is the x-axis that goes horizontal. And so if we're looking at the pink line, the point where it crosses right here is called the y-intercept. That's the point where that pink line crosses the y-axis. This point down here is called the x-intercept because that's where the line crosses the x-axis. Okay? So looking at just the pink line, we can see that the y-intercept is 1, 2, 3, 4, 5, 6, 7, and we would call that 0, 7 for the y-intercept. And if we look at the x-intercept, that'd be 1, 2, 3, 4, 5. So that would be 5, 0 for the x-intercept. And we can actually use those 2 points to create the equation of the line, but we're not doing that right now. I just wanted to make sure you remember what the x and the y-intercepts are. Okay? Linear equation, x-intercept, y-intercept. For it to be linear, it can only have one x-intercept and one y-intercept. Okay? Now, if we look at this red line right here, we call that a Yeah, horizontal line. And the horizontal line never crosses the x-axis, so it doesn't have an x-intercept. So that's okay. You can have a line that doesn't have an x or a y-intercept, but it's got to cross at least one of those in order for it to be linear. Okay, so I go up here 1, 2, 3, 4, and so I notice that that is 0, 4. So the x-intercept for this red line would be 0, 4. It's a weird one because there is no y-intercept, but we'll look at the equation for that at a later time. Now we were able to just look at a graph and we were able to point out the x-intercept and the y-intercept just by looking at it, because we could look at the axes and we could pick out where it crossed the x-axis or the y-axis. Notice though that when you have a y-intercept, the x-coordinate is 0. That's important to deal with. And when you have an x-intercept, the y-coordinate is 0. So let's say we're given a table. Somebody had to drain their swimming pool, problem with the lining, who knows what it was, and they timed it to see how long it would take to drain the swimming pool. At 0 hours, there were 1,080 gallons in the pool. What does that mean? Well, when the pool is full, at 0 hours, there's 1,080 gallons in the pool. Okay, that's how we interpret that number. So if x is 0, then that must be the y-intercept. And I'll say that again. When x is 0, just like over here, that's our y-intercept. That's where this line, if we graph this line, that's where that line would cross the y-axis, is 0, 1080. Because that's how many gallons were in the pool at the beginning. You'll get to use this. The y-intercept is typically always what's happening at the beginning. Now we go down, and after 2 hours, after 6 hours, after 10 hours, after 14 hours, there are 0 gallons of water in the pool. What does that mean? It means it took 14 hours to drain the pool. Okay? Now there's no water in there. So my y value is 0. Well, when my y value is 0, then that's where the x-intercept is. So this must be the x-intercept. That is where the line is going to cross the x-axis. Okay? Now this is a real-world problem. There's a definite beginning and a definite end to this situation. We got 1,080 gallons in the pool to start with. That doesn't change. And then at the end, after 14 hours, there's 0 gallons. Okay, we're not going any farther. We can't have a negative number of gallons in the pool. So it's a definite beginning and an end. So those y-intercept and x-intercepts help us to identify or explain what's going on. When the x value is 0, that means it's empty. When the y value is 0, that means it's full in this situation, because that's where it started at. You need to be able to interpret the x and y-intercept to know exactly what they mean. Now that we know exactly what those x-intercepts and y-intercepts are and how to find them in a table, we can use that information to graph an equation that's in standard form. You see how this is standard form? ax plus by equals c. So 2 is a, 4 is b, and 16 is c. And then I have the x and y there, which would be points on the line. I would plug in a point and see if it would be true, and that could be point on the line. Okay? So we'll get to more of that later. But when we talk about using the x and y-intercept, let's talk about the x-intercept first. Okay? Remember when we talk about an x-intercept where it crosses the x-axis, the y value is 0. So when I'm trying to find the x-intercept, then I'm going to plug in 0 for y. Okay? Now, one of the ways I could do that is I could make this 4 times 0, 2x plus 4, 0 equals 16. We know that 4 times 0 is 0, so I've got 2x equals 16, so x equals 8. Okay? So in this case, x equals 8. That's my x-intercept is 8. So I'm going to go across to the x-axis, and I'm going to put a point right there because x equals 8 is my x-intercept. Now, for the y, I'm going to draw squiggly to just keep it separated. For the y-intercept, the x value is 0. So I'm going to go back to my original equation, and I'm going to plug in 0 for the x value. So when x is 0, then I'm going to come up with my y-intercept. So I'm going to do 2 times 0 plus 4y equals 16. And I know that 2 times 0 is 0, so I don't need to write anything else. So 4y equals 16, y equals 4. So my y-intercept now is going to be 4, which is the same spot as that one. So then I would take a ruler, which I do not have with me right now, and then I would draw my line, and I'll try to freehand it, which you should never do. And we get something close, and there is the line, okay? With the x-intercept at 8 and the y-intercept at 4, as long as I have those 2 points, the x and the y-intercept, I can connect them and keep going, put arrows on the end because it's a line, and there's my line. Just to recap, here's the hint that I use, okay? For the x-intercept, I'm making y equals 0. Well, instead of writing this all out, I just cover it up. Because we know it's 0, so it's not even there. So now I have 2x equals 16, x equals 8. And yes, you're welcome to do that. And in the second case, when I'm trying to find the x-intercept where, the y-intercept where x equals 0, I just cover that part up. Because I know it's going to be 0. So 4y equals 16, y must equal 4. It's not always that easy to calculate. Sometimes you'll have decimals or fractions or crazy things. But either plug in the zeros or just cover it up to make it look like it's 0. It's hidden. The last thing that you need to know in this video is pretty important, okay? Domain and range. Talked about that before. For linear equations, for all linear equations, okay? For linear equations, the domain is all real numbers, but there's another way to write it, okay? One of the ways that you might have learned to write it is with a capital R with 2 lines, okay? That's all real numbers. Another way you can write it is you can do the negative of infinity is less than 0, we're talking domain here, so I should put that domain. And the domain is the x is less than x, which is less than infinity, okay? And you always put it in brackets, and you put a D in front with a colon. And I know I did that all kind of backwards. But another way to write the domain for a linear equation is the negative of infinity is less than x, which is less than infinity because it goes on forever. There's not a number that I can use that won't work. Okay, that's for the domain and the range. In the range, I would write the same way, except I would put an R for range. Negative infinity is less than x is less than infinity with brackets on the outside, and that would be the range for the y values, okay? Every once in a while, I said every linear equation, every once in a while we get a crazy one. Like this red line right here, all of the y values are 4. Every point on here has a y value that's 4. So in this case, for that line, the range would be y equals 4 because that's what it is. All of the values are 4. But for all other lines that are not vertical or horizontal, then we have the domain is negative infinity is less than x is less than infinity, and the range is negative infinity to less than x is less than infinity. Can you write both? Absolutely. You can put all real numbers, you can put this symbol, you can put that, and it may just say all real numbers. You just have to know all of them because you never know what it's going to appear like on a standardized test. And here are your practice problems for this video. The only thing I want you to do is to state the x-intercept and the y-intercept for each situation. First, you're given a table, so tell me what the x-intercept and the y-intercept is. And then you're given an equation in standard form. ax minus or plus by equals c. Tell me what the x-intercept is and the y-intercept. Take a picture of your practice problems and submit it in Edmodo.